This is the fourth video in the piecewise and rational functions unit. It's on slant asymptotes. Sometimes slant asymptotes are called oblique asymptotes, which you can see here. This is how you spell oblique. We're used to seeing asymptotes that are either vertical or horizontal, right? Here's vertical, here's horizontal. And so you see here on this particular graph, it still has a vertical asymptote, but it has no horizontal. Instead, it has one. Remember that an asymptote is just a line with a slope and a y-intercept, and that's your oblique. This one is very oblique. Same deal here. And then you can see that the graph comes in an opposite area. It either goes out like this, or it will be inside like this. Here's a review on how to find whether a rational function has a horizontal asymptote. You want to look at the highest power in the numerator and the denominator. If those powers are the same, like this example right here, both are x squared, then it has a horizontal asymptote, and further it is y equals 2 over 3, or the coefficients of the highest power. If it has the highest power in the denominator, like this one, then the horizontal asymptote is the x-axis, y equals 0. The third possibility is if the higher power is in the numerator. And then we learned that this, if it's big on the top, if it has the highest powers in the numerator, there is no horizontal asymptote. Okay, so that's awesome. And I'd mentioned before that if there is no horizontal asymptote and the power of the numerator is 1 more, now it doesn't have to be 2 and 1, it could be 3 and 2, 4 and 3, whatever, but it has to be 1 more on top than the bottom, then there is a slant asymptote. And that should make sense, right? Because what you're going to do to find the slant asymptote is you're going to divide the numerator by the denominator. So if you're dividing this top power by the bottom power, the difference will be 1, which will be a linear equation, which is the equation of a slant asymptote. So you're going to find the equation of the slant asymptote by dividing the numerator by the denominator and discarding the remainder. So you don't have to worry about the remainder, but you are going to be using long division. Okay, here's their first example. We look here to see, does it have a horizontal asymptote? So the highest power in the numerator is x squared. The highest power in the denominator is x. The numerator is higher, so it has no horizontal asymptote. However, 2 minus 1 is 1, so it does have a slant asymptote. Okay, so we are going to divide the numerator by the denominator. All right, and we say x goes into x squared 1 time, so x squared plus 2x, and then change the signs because we're subtracting. So this is negative 4x plus 1. So then I'm going to multiply that by minus 4. And honestly, at this point, as long as you have the correct thing, we don't really care what the remainder is. The equation of the slant asymptote is x minus 4. So it has a y-intercept of negative 4 and a slope of 1. All right, let's try this again. First thing we want to do is we want to see, does it have a horizontal asymptote? And the highest power in the numerator is x squared, the highest in the denominator. It is 1 apart, and so it has a slant asymptote. So I'm going to divide the numerator by the denominator and discard the remainder. So x, so I have x squared minus x, subtract, plus 7. So the slant asymptote is x plus 7. All right, so we're going to try this one more time, only this time we're going to actually sketch it. So we look here and we ask, horizontal asymptote? No, but it does have a slant. So I'm going to do x squared minus 3x minus 4 divided by x plus 2. So I have x squared plus 2x, subtract, negative 5x minus 4 minus 5. So there's a slant asymptote at x minus 5. We have vertical asymptotes at, or vertical asymptote at x equals negative 2. And then we have x-intercepts. I'm taking the numerator, so this would be x minus 4, x plus 1 equals 0. So I have x-intercepts at 4, 0, and negative 1, 0. Okay, so we're going to graph this, and I have a vertical asymptote at negative 2. This x equals negative 2. It's not a perfect square, right? So it's going to go opposite at that. And then it has a 1, 2, 3, 4, 5. It has a slant asymptote here. Let's see if I can draw it. Beep, 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 beep. Okay. And this goes way down here. In fact, I think I'm going to erase that. It's kind of in the way. So draw this and draw this here. Okay, it has at 4 and negative 1, 0. So I know it's going here. So remember, with a slant asymptote, they're across from each other. So it has to do this one. And so instead of being on the sides, it'll be down here. And that's the graph. So you still have to know how to do long division. You still have to know how to find your vertical asymptotes, your x-intercepts. I didn't need a y-intercept. I could find it. It's probably down here somewhere. But with a slant asymptote, you know that it's either going to be this in a V or it's going to be here in a V. And the x-intercepts told me where it would be. All right, so this is what we're going to do in class, a ton of these when you come to class. So I'll see you then.